Hi, hello. Thank you for this assignment. I'd like to share a small update on the progress. I just completed almost everything. Only this part is pending where I use Cucumber as test runner. So I got to leave to another place today. So I'll be coming back only after 2 days. Maybe once I'm back, I'll try to add this part alone, but rest all done. So the purpose is to create a test plan and indicate automation implementation. I did follow the specifications and I went with Playwright with TypeScript. To the best of my knowledge, I tried to adhere to these requests. So the repository is created, including the README file on how to set up. It is successfully running in GitHub Actions. Once it runs, it's gonna generate artifacts. So which is here. We can download this, which is HTML report. So the report is downloaded. This is where it is. It's going to give us index.html file that is passed. We can see the report. We'll just come back to here. Getting back to the assignment, I did actually set up the workspace. I have created two sources. Selecting one card is easy, but I would like to filter out any card that is available here. And I've created a webhook destination. This is the destination, and I've got your Postman collection. And I sent an event, and it is being tracked. I have few events generated, four events by now. I just made a quick presentation so that you can get idea on how this is achieved. To achieve that task, I need to pass through these pages. First thing is all about logging in. I know we don't have two-factor authentication enabled, so here I need to click. I'll do it later, and this will take to this page where I need to click on go to dashboard, and this will launch dashboard. So when we are in dashboard, I see that default tab is connections, and here we are interested in two things. One is the getting the data plane URL. Other thing is write key for the right source card. Once we get this data plane and write key, we're gonna click on destination, which will take to this page, and here we got to validate these metrics. This is my understanding. And here I could see three levels of pages. Obviously the sidebar is common for everything, hopefully for the entire application. If I click on connections, this is the page I see. This is the level one. And if I click on sources, this is the page. Destinations, this is the page. Transformations, this is the page. If I click on new source, it is taken to the directory. There are interconnections among the pages. When I'm thinking about page object model, this is the level one. And if we click on this destinations, we are getting into level 2, which is the details page of the destination. I'm calling this as connections page, and I'm calling this as destination details page. And within this destination details page, we have several tabs, and inside we have settings tab, transformation tab, and sources tab. This is something I have considered to tackle, considering we have hundreds of sources and destinations, and how this could scale in future. Coming to the folder structure, we have the sections: collect section, activate section, and at a root level I have created a folder called engine, and engine will accommodate web folder and API folder. Here we have collect as the wrapper, and we're gonna have a collect module. Same way tomorrow we'll create for activate and settings, whatever the menu sections we have, so that it will be easy to follow. If we see inside this collect, we have the core folder, pages folder, states folder, and steps folders. For example, let's focus on only this connections page. Within this connections page, they'll have its own locators and own methods that have to implement the contracts. So here, in any traditional page object model would have locators and actions for those locators. We have introduced a new pattern called state here. The traditional convention is come here, pick up this data plane URL, and pick up this write key and pass as parameters to some other method and do whatever you want. Here we decided to go with a state pattern. We'll just see what is state. This is our traditional page object model. We have connections page, so which implements the iConnect interface, which is in the contracts file. According to the page object model, we have the locators that we have here. We have a data plane URL. I'm storing the locator for all sources cards and all destination cards, because it is not about just a single card. We should have a generic locator that highlights all the cards, and we should be able to dynamically filter it based on the card type or card name or card status. That's the whole idea here. And then we have page actions like navigate directly to connections page and a lot of things. And here we are introducing something called page state. That means this particular connections page will have its own page state. So let's see how that looks. This is the connection page state. This is going to be initialized inside the connections page. So if you see here in this connections page, we need to store two things. One is data plane and the card which we are operating. So the story is not about single source card. We have multiple source cards and multiple destination cards. So every time we need to know which card we are operating on. So this is where we want to see a data plane URL representing this URL. Current source card, this one. Current destination card, this one. And here are some getters and setters. I'll also show how these are being invoked by other modules. and finally a reset method. So this will be our state. That means once we land here, we're going to load this data plane URL to the state. If you see this current source card, this is of type source card. See the current destination card, this is of type destination card. How this would look is, maybe I can show engine web collect states connection page state. The source card has got ID, name, status, write key, and type. Destination has got these attributes. And this ID, name, status, write key are nothing but these ones. We have HTTP, which is the type of the card. This is the name, and this is the write key, and this is the status. Enabled is the status. So we're gonna capture it. This is a generic idea on the folder structure and how a new concept of state was introduced to support our RudderStack application. And I'll switch to here. I'll copy this and just do git clone, or I can clone with GitHub desktop. Once it is done, we need to open here. This is how the folder structure looks like. I'm not interested in getting into everything until I show how the solution works. Go to the new terminal. We just need to do two checks. One is the node version, and Java is optional because we are using it for LEO report. So we ensure node and Java is installed, and you just need to do npm run setup. This is going to do all the setup automatically. So this is how we are doing in the GitHub actions as well. What I'll do is I'll just create a new test here. Collect http event dot test dot yes. So first thing first, we have a base test already configured within this framework. We got to import that base test. Once the base test is imported, we're gonna initialize that base test, and it's gonna accept first parameter as the test name itself. So as of now, I'm naming it as RudderStack HTTP webhook event flow, and tag, I'm just making it as a simple smoke testing tag, and then within this function body, we got to write our actual test. So once we have this ready, within this argument space, we can start using our page object model language. We call this as login page, and we can start typing login, and automatically it will suggest login page steps. We got to invoke this login page steps here, and just give dot, and it's gonna see what actions we can perform. So the ideal action is navigate. Fresh, as of now, we are in the production environment. QA and other environments URLs could be different. Everything is preloaded into this constant called test config. This will have almost all the details attached: related test data, environment, and retries. Everything can be controlled here. So using this test config, we got to pass the base URL. This will automatically load the base URL. We can actually verify if the login pages button is disabled or enabled. I'm not doing that. I'm simply logging into the application. So again, from the test config, I can actually grab credentials, grab the username, credentials, I can grab the password. Automatically that environment's credentials will be pulled directly to here. Once we log into the application, sometimes this two-factor authentication, I'll do it later, would come. That was also handled directly inside this for now. And here we are in the connections page. Just type connections. We're gonna have connections page steps. So whatever we want to perform on this page, we have this readily injected. The first thing we'd like to do is load this data plane URL and load our desired card. So this is where our state concept comes into picture. For now, let's load data plane URL. When we invoke this, this will automatically grab this and load this to the state of the connections page states. Now connections page will also have this called get state. So let me demonstrate. For example, I have the state variable here, and if I do console.log state does have data plane URL. So let us quickly run this and see. Okay, I missed to add the await statements. Okay, let's see now. So it has logged into the application, and we could see this has printed the data plane URL. So we are loading the data plane URL from here. I'm interested to interact with this card. For that, we have a method called load source card. We need to give the name of the card and the type and status. So automatically it will go ahead and identify that card within this list. My HTTP source. Let me grab this. For that type, we have enums. Source types, I'm gonna set it to HTTP. Third parameter to accept is the status. Card status, enabled one. What we are saying primarily here is, hey, just go and see all the cards matching this name, matching this type, and matching this status, and just load that into our state. We can read the state. We have current source card, which is this card. If you do dot, you can see all the attributes. So this does have an ID internally at the DOM. Then it does have name, status, type. So we can, let's say we want to read out the right here. That means essentially if we run this now, this should go and grab this particular card's write key. So it is logging in and loading the data plane to URL, and here we see it has grabbed the right key. Here we have given these filtrations. Based on that, it has filtered the right card and printed the right key. So at this point, once we grab here, we are supposed to make an API call. For that, also we have the client attached, RudderStack API client. It will accept data plane URL and right key. We already have data plane URL. We already have data plane URL here. We're gonna grab that and pass that as the first one. Then we have write key, which will be the second argument. Return RudderStack client. And using this, we can switch the context from UI to the API. These are the APIs that are available, and we are interested to make an track event. I have a sample event which I took from the documentation. This will actually send an event automatic. Once the event is sent, our next target is to click on this destinations, and from this connection page steps, we got to click on the destination card. We can leave the name undefined and simply pass the destination type to be webhook, and we can also leave rest of the things undefined. That means we are technically asking it to click any card that has the destination types webhook. If you have more than two cards, we also have this index. If you pass the index one, it's gonna take topmost one, the greater one will be the last. This is the connections page. Once we click this destination card, we'll go to the destination details page. That means we are seeing the details of this particular destination. Now we got to have destination details page. Okay, once we have the destination details page, those actions we can invoke here. And if you see, third level pages are automatically attached to this. We could see, just like how we are seeing the UI, we have sources tab, events tab, transformation tab, events tab, source tab. As of now, we are interested to only in the events tab, and this will have a method called navigate. Once you do this, it will automatically navigate to this events tab. We can call the same details page events tab, and we have an action called refresh. So that will refresh this details page events tab, validate the metrics, which are these three cards. And this will accept primarily three attributes: expected delivered, expected failed, and expected rate. Events will not populate immediately. I'll set it to 4 is expected failed, I'll give it 0. This one rate, I can mark it at 0%. Fine. So this is running in the headless mode. So let's run this and see how this looks. But what I'll do is, we have 3 environment files. We are currently running this QA for now. Even this API version you can control. Page to page navigation, action timeout, test timeout. Here I'll set this headless equal to false. So for the sake of GitHub actions, I set it to. Let me run this in QA mode. This should open the browser, and it should go login, skip the things. Even it will handle this AI. We are here, and it is going inside events tab. Verification done, passed. So for the report, all the commands are listed in the package.json. If you want to see the QA environment reports, run Elio QA. So once we loaded the data plane URL in the source card, write key, and whatever it is, when it makes an API request, this request is attached. If you could see, this is the URL which we hit, and this is the response which we received. This API portion is done. We'll switch to the UI part, and we are clicking the destination card, navigate to the events tab, refresh events, and finally check if the elements are like this. In case if it fails, what I'll do is, I'll just make this as 10%, the failure rate. Okay, let's test it now, and it is expected to fail. And by the way, this is the most stable application I have ever seen. See, now this has failed. I'll just copy this and see I'll show the HTML report. So this is how the failure scenario looks like. It's gonna point out to the exact place where it failed, and this is the entire test flow, and this is the exact step: validate event metrics, and it will attach the screenshot, and it will attach the trace and video as well. So it went inside, went to events tab, refreshed, and this is where the validation failed. And the trace feature is something I like within this Playwright. So we have the time travel feature. You just go to any place and we could see what is happening. And particularly the current structure allows you to use this time travel feature to the fullest. You go to the login page when you're filling password, clearing the locator exact level, and sometimes we can also monitor the what is happening in the network tab. Yeah, so that is pretty much about it. And if I have to touch anything, web actions, which is then wrapper on top of the Playwright actions. Then we have small modifications for we are using the Winston logger. All the timestamps which we are seeing here, this is actually coming from this configuration. And how this works at the GitHub level is, So we'll ask the user to input a choice, which environment you want to run. Let's say he entered choice to be QA. So first we'll define in which machine we got to learn. There are some steps: checking out the code, setting up the node, installing the dependencies. So it's in one command setup. We are just printing out something for the log purpose. So whatever we are using, we are just doing the logging. We are doing the npm run test, and here I'm giving the environment. This is how it is configured in the package.json. And once it is done, we are actually uploading the artifacts, because the reports will be generated into this output folder. And here also hierarchy will be clear. So we these are the dev reports, QA reports, and production reports. So yeah, this is something I thought of implementing within what I know about RudderStack. It's a great learning, and thank you so much. And it is pleasure to submit this.